In this video, we will discuss about the vector calculus. So we start the new topic, that is vector calculus. So before starting the main topic of vector calculus, we will start the basic definitions related to the vector. So first we start the definition of vector and scalar. तो पहले तो हम ये पता करेंगे कि स्केलर क्या होता है और वेक्टर क्या होता है. So first we start with the definitions. Definition. So definition, first we take the definition of स्केलर एंड वेक्टर क्वांटिटी. तो पहले हम डिफाइन करेंगे कि व्हाट इज स्केलर एंड व्हाट इज वेक्टर क्वांटिटी. क्वांटिटीज. So now, so we define this as all physical quantities. All physical quantities generally two types. We have two types of physical quantity. Two types. Type 1, which have only magnitude. So we write down those having magnitude only. Those have magnitude only. And the second type is those having magnitude and direction. Magnitude and direction. So now, on the basis of these two physical quantity, we define the scalar and vector. So first we define a scalar. For defining the scalar, so the physical quantities, which have magnitude, only, but are not related to any definite direction. Any definite direction is called the scalar quantity. Direction is called scalars. So what are the example of scalars? So the example of scalars are, that means having mass, length, volume, density, speed, temperature, work, etc. So these are the example of scalar quantity. So which have only magnitude but doesn't have any direction. So now we move to the next definition, that is the vectors. Vector की definition क्या है? So for defining the vector, those physical quantity which have a magnitude as well as direction. So we write down magnitude as well as direction. So is called vectors is called vectors. और डायरेक्शन भी कैसी होनी चाहिए? That is definite direction. So we have definite direction, so is called the vector quantity. So we write down is called vector quantity. So is called vector. So which have only magnitude is called scalar, and which have magnitude as well as direction is called the is vector quantity. So now we take the example for vector quantity. So the example of vector quantity, so that means force. So when we are going to apply the force, we have some direction, then velocity, next acceleration, next displacement, moment, momentum. We remember one thing, note, finite rotation of rigid body is not a vector. तो जो finite rotation होगा, that is not a part of the for a rigid body, not a part of the vector. Now, so after understanding the definitions of vector and scalar, we move to the representation of vectors. A representation of vectors. So how to represent the vectors? So for representing the vectors, because the vector having magnitude as well as direction, so we write down as the vectors has both magnitude and direction. So this can be represented by a directed straight line segment. Directed straight line segment. So directed straight line segment. So we can take a straight line which have some direction. So that means this is a straight line. We provide the direction, and we have the initial point, that is P, that is terminal point, that is O and P. So OP, we have a straight line, so direction towards to P, and we take as vector A. So this vector A, so we represent this A, so that is vector A form. So this is the representation of vectors. So OP, generally we denote this vector OP. So we denote it as vector OP. So vector OP is equal to vector A. So O is the initial point or PV the terminal point. So we remember this is the initial point and this is the terminal point. So initial point and terminal point. So we represented the vector always by an arrow. So you have also remember this thing. So when we represent the vector, so that vector will also represented by an arrow. So now after understanding the representation of vector, we move to the next definition, that is the module. We read as module, or we can say that the modulus. Module or modulus. So the positive number, we write down the positive number which measure the magnitude of a vector is called its mode, in short, or we can say that the modulus, or we can say that module. So the modulus of the vector we represented always the modulus of vectors are represented as, so when we have vector A, so then its module we can represent it by module of A, that means, so let A be the vector, so then the modulus of vector A is denoted as modulus of A. So modulus always a scalar quantity. So we can understand that, suppose vector A having element 2i plus 3j plus 4k. So then when we calculate the modulus of vector A, mod A, so this gives us square root of 2 square plus 3 square plus 4 square. So we can write down this as 4 plus 9 plus 16. So this will be the 29. So modulus of vector A, which is 29. तो जनरल केस आप लिख सकते हैं, जैसे कि वेक्टर आर है, वेक्टर आर वी राइट डाउन एज एक्स आई प्लस वाई जे plus zk. So when we obtain the modulus of vector r, so this can be written as x square plus y square plus z square. Now we move to the next definition, that is the unit vector. So next definition is unit vector. So a vector, that means unit vector which have modulus is unity. So a unit vector is one whose modulus is unity. Whose modulus is unity. Unity means 1. So this we can represent it, let A be the vector. Let A be the vector. So then unit vector of A, we write down as unit vector of vector A. We can write down A cap. अब इसको रिप्रेजेंट करेंगे यूनिट वेक्टर को A cap से, A cap which is equal to vector A upon modulus of A. So vector A upon modulus of A. So this is the unit vector. For representation of unit vector, So A cap equal to vector A upon modulus of A. So now we move to the next definition, that is the zero vector or null vector. Zero vector और null vector. तो बेसिक डेफिनेशंस हमें याद होंगी तभी हम आगे नेक्स्ट टॉपिक्स को इजीली अंडरस्टैंड कर पाएंगे. So we remember all the definitions. So if the module or modulus of a vector is 0, so then that vector is called zero vector. Vector is called zero vector or null vector. अब कैसे एग्जांपल्स हो सकते हैं जीरो वेक्टर और नल वेक्टर के लिए? So that means we can say that direction is arbitrary. In null vector denoted by zero vector, we denote it as zero vector. Simply we denote it as zero vector. So or basically we have some representation. We have A vector, B vector. Okay, so such type of vectors are called zero vectors. We write down are zero vectors. Now we move to the next definition, that is the equal vector. So for equal vector, the two vectors are said to be equal. Two vectors are said to be equal if they have equal magnitude. If they have equal magnitude and are parallel and also have same sense of direction. Same sense of direction. So then the vectors are said to be equal vector. So suppose we have this line. So the direction from that side. So this can be represented as. So here we have point E. We have a F. And second we have A, B. So then we can say that AB is equal to CD or CD equal to EF. D we can consider here as D. So we can say that AB, vector AB equal to vector CD is equal to EF. So they are equal vectors. So after understanding the equal vectors, we move to the like vectors. So for like vectors are vectors. We write down it. Like vectors are vectors having same sense of direction. having same sense of direction. So they are called the like vectors also. Now we have some operations on vectors, that means addition of vector. So we write down as addition of vectors. So for addition of vectors, suppose this is vector B, and here we have vector A. So when we add these two vectors, so that means we can take as this is OA and B. So when we have this is vector A, so the direction of this is vector A. Now this is vector B, and when we add OA, so that means this is our OB. OB, the direction of OB from O to B. So that will be the A plus B. So A plus B, so that is our addition of vectors. So we have a OA vector, OA equal to A, and AB is equal to B. So then OB equal to OA plus AB. When we obtain the subtraction, so same as subtraction of the vectors. So subtraction of the vectors, that means we define as subtraction of vectors. So to every vector A, there correspond to the vector minus A, such that vector A plus minus A is equal to 0 vector. So we can say that vector OA equal to A vector. So then we take corresponding vector, that means AO. So AO equal to minus A. So we can say that, so that vector OA plus AO is equal to OO is equal to null vector, 0 vector. So basically we can say that minus A vector is the inverse vector of A for the operation of addition. Now move to the next multiplication of a vector by a scalar. So multiplication of a vector by a scalar. अब किसी भी वेक्टर को स्केलर से मल्टीप्लाई करना हो, तो हाउ टू मल्टीप्लाई द स्केलर. So suppose we take one scalar, let m be the scalar, and a be the vector, So then we defined MA. We defined MA. So this MA means whose magnitude is m times of the magnitude of A. So this is m times magnitude of A. So directly, suppose we have two scalars. So we have two scalars m plus n, and we have vector A. So when we proceed the distributive law, so this can be written as m A vector into n A vector. And suppose we have two vectors or one scalar. When we have two vector or one scalar, so two vector or one scalar, so we write down as vector A plus vector B. So this can be written as m into vector A plus m into vector B. So this is the multiplication of vectors by a scalar. Now we move to the next definition, that is the coplanar vector. So next definition is coplanar vector. कोप्लानर वेक्टर, कोप्लानर मत मीन सेम प्लेन। तो यहाँ पर हम लिख सकते हैं कि व्हेन थ्री और मोर वेक्टर्स, थ्री और मोर वेक्टर lie on a same plane, lie on a same plane are called coplanar, coplanar वेक्टर। अगर इसको फॉलो नहीं कर रहा है तो उस केस में क्या होगा, तो वी कैन से दैट अदरवाइज नॉन कोप्लानर वेक्टर, नॉन कोप्लानर वेक्टर। So vectors are not planar, so that means they are non-coplanar vector. Now we move to the next definition, that is the unit vectors I, j, k. So the unit vector I, j and k. So unit vectors I, j, k. So basically we represent the vector I, j, k on the basis of the direction. So on the basis of the direction we consider, so this is our O. Here we have x-axis. Now we consider this as y, and this we can consider as z-axis. And we take this is vector r, and p be any point. So we take as now. So we take three axes, ox, oy, oz, and let a vector op, which is equal to vector r. OP equal to r. So we draw a rectangular parallelepiped with we consider OP as a diagonal, and as along OX, OY, OZ, and we consider here we take as this is our A, here for Y we take as B, and this side we take as C. So the components, that the length of its components we consider as OA, OB, and OC along X, Y, and Z. So we write down if I, J, K be the unit vectors, in the direction of OX, OY, OZ respectively. So then vector OA equal to XI, vector OB is equal to YJ, and vector OC is equal to ZK. So we can write down so that the vector R, which is vector OP, so that's OP will equal to vector OA plus vector OB or plus vector OC. So that is equal to XI plus YJ or plus ZK. So we always remember, so this is for general case, vector R we represented as Xi plus Yj plus Zk. So we also mentioned that it is clear if R1 and R2 are two vectors, so then vector R1 is equal to x1i plus x2j plus x3k, and vector R2 we represented as x2i, vector I, x x1, x2, x3, or here we can consider as y1, y2, y3, or we can write down in the form of x1, y1, z1. So as per convenience. So here we can write down as x1, y1, or z1 if we are considering x, y, z. So we write down or x1, x2, x3 you can also write down. So x1, y1, z1. For second we can write down as x2, y2, or z2. So here we can take x2. Now we write in y2 or plus we write down as z2. So when we add two vectors, means r1 plus r2, so vector r1 plus vector r2, so then the sum we can write down as x1 plus x2 into vector I, or y1 plus y2 into vector j, or plus z1 plus z2 into vector k. So now we move to the further, that means if alpha, beta, and gamma be the angles which OP makes with coordinate axis OX, OY and OZ respectively. So then X will be R cos alpha, Y will be R cos beta, or Z will be R cos gamma. So unit vector, we write down unit vector of vector R. So that can be represented as R cap. So R cap is equal to vector R upon modulus R. So this can be written as xi plus yj plus zk upon vector R, or where vector R is equal to, so we can write down this as x upon R into vector I, y upon R into vector j, or z upon R into vector k. So you can write down this x is equal to R cos alpha. So that means this will be equal to cos alpha into vector I, cos beta into vector j, or cos gamma into vector k. So cos gamma into vector k. So the x, y, z are called the coordinate of the point P. So these x, y, z are called the coordinate of point P. So this point P, so we can take the coordinates of point P is x, y, z. Or we write down as cos alpha, cos beta, or cos gamma. Cos gamma are called direction cosine, of OP. So when we obtain OP square, so this OP square is equal to OA square plus OB square or plus OC square. So this gives us R square is equal to X square plus Y square plus Z square. So this we can write on vector R to the modulus. So that means square of magnitude. So we can say that the square of magnitude of vector R. तो वी हैव ऑलरेडी डिस्कस्ड, हमने पहले ही डिस्कस कर दिया, अगर वेक्टर ए हमारा a1i है प्लस a2j और प्लस a3k, तो देन वी राइट डाउन द मॉडुलस ऑफ वेक्टर ए, so this will be a1 square plus a2 square और प्लस a3 square. नेक्स्ट एग्जांपल, अगर हमें यूनिट वेक्टर निकालना है, तो यूनिट वेक्टर इन द डायरेक्शन ए, unit vector in the direction of vector A, so you can calculate this way. So we write down AI, AJ और प्लस AK अपॉन A square plus A square plus A square. So we take A as common, so vector I plus J plus K upon root 3 into A. So because this is 3A square, so we take square root. So now we can write down as vector I plus vector j plus vector k upon root 3. In this case, if vector A is equal to 0, so vector A equal to 0, so in this case we have A1 equal to 0, A2 equal to 0, or A3 equal to 0. So all three are 0. So in this case I, j or k, I, j or k are called non-coplanar, They are not in a same plane.